Hello everyone, my name is Ogeneti Mamogo and you are welcome to Oakscam Academy. Now if you are new to my channel, kindly hit the subscription button below, also like, share and of course avail yourself to the lesson so as not to be left behind. Welcome back. So in today's lesson, we're going to be continuing from our previous lesson, which was under the topic empirical and molecular formula. So in our previous video, we learned about how to calculate empirical formula. If you are yet to watch that video, kindly check it out in my channel. It's titled Empirical and Molecular Formula, but emphasis on empirical formula. So for this class, for this particular lesson, we're going to be learning how to calculate molecular formula. So we have two questions on the board and we're going to be going through them one by one. Okay, so the first question on the board, it says a compound contains 86.88% of carbon and 13.12% of hydrogen, and the molecular weight is 345. What would be the empirical and molecular formula of the compound? In our previous video, we explained what empirical formula and what molecular formula was. But just as a recap, remember we learned that empirical formula is the simplest whole number ratio of atoms in a compound. So that is the simplest ratio of atoms in a compound, while your molecular formula is the actual number of atoms of elements present in a compound. So you can simply say the empirical formula is the simplified version of molecular formula. So empirical formula is the simplest ratio, while molecular formula is the actual number of atoms of elements present in a compound. So if we understand that, I believe we should be able to solve this. Now, remember when we solve for empirical formula, I think in my previous video I mentioned that when you are solving for molecular formula, you must first of all solve for empirical formula. So it doesn't matter whether the question asks you to solve for empirical formula or not, as long as you are trying to solve for molecular formula, you must first of all solve for empirical formula. So please don't forget that. So I think we can proceed now. So first things first, when we are solving for empirical formula, remember the question says what would be the empirical and molecular formula of the compound. As I said earlier, even if the question had not mentioned empirical formula, for you to calculate molecular formula, you must first solve for empirical formula. So let's solve for the empirical formula of this question. So the first step, as we learned in our previous video, is to write out your what elements. So we have carbon and we have hydrogen. So write their symbols. That's the first step. So what is the next step? The next step is to write the percentage attached to those elements. So the question told us that carbon is 86.88%. So we write it 86.88. And then we're told that hydrogen is 13.12%. So 13.12%. Now what is the next step? The next step is to write the mass number. Please don't write the atomic number. What you are writing is the mass number. So what is the mass number of carbon? In this question we were not given, and that is why it is very good that you are familiar with your mass numbers. Okay, so you must know your mass numbers by heart, at least for your first 20 elements. So please take out time to learn the mass numbers of your first 20 elements. So what mass number of carbon is 12 and the mass number of hydrogen is 1. So now that we have written the mass number, we're going to be dividing. So we know that 13.12 divided by 1 is 13.12. So we're going to be dividing 86.88 divided by 12. So what we have is 7.24. 7.24. Now please take note, the answer you get when you divide must be two numbers after the decimal. So even if you had 7.2, you are going to have to write 7.20, because why? You must have two numbers after the decimal. So please take note of that. So now that we have divided and gotten our values, the next step is to divide by the lower number. So out of these two, which is the lower number? 7.24, right? So that's what we're going to be dividing by. So 7.24, 7.24. We're going to be dividing this. So if you divide this by this, you know it is 1, right? So let's divide 13.12 divided by 7.24. So what we have is 1.812 and so on. So 1.812. Okay, so 1.8. So we can call it what? 2. So we can call this 2. So since this is 2, meaning that our empirical formula is what? CH2. Why is it CH2? Remember, in chemistry we do not write 1. So because we don't write 1, the formula is simply CH2. So this is the what? Empirical formula. Now, had it been what we had here was, remember we said 1.812. If we had 1.5, what you would have had to do is multiply both sides by 2 to get a whole number. 1.5 times 2 is 3. But because this is 1.8 going to 1.9, we can simply round up to what? 2. But if it was 1.5, please, you are going to be multiplying both sides by 2. So now we have the empirical formula. We want to now calculate for the what? Molecular formula. How do we do that? So to calculate the molecular formula, what we're going to be doing is we're going to be adding up the mass numbers of your empirical formula. So the mass number of carbon is 12 plus the mass number of hydrogen is 1, but don't forget there's a 2 attached to it. So times 2 equals to what? 14. So we know that 12 plus 1 times 2 is 2, which is 12 plus 2. 2 gave us what? 14. So let's call that 14N. So this is the relative molecular mass of your empirical formula. Now to solve for the molecular formula, we're going to be dividing this by the molecular weight that we're given in the question. So our molecular weight is 345. So I'm going to be saying 345 divided by what? 14. That's N is equal to 345 divided by 14. So if we do this division, what we are going to have, so let's quickly do this, 345 divided by 14. So what we have is 24.64. So if you round that up, that becomes what? 25. So let me write, so this is what we have, but therefore equals to what? 25. So I've gotten 25. So what are we using 25 to do? I'm going to use this 25 that you have gotten to multiply your empirical formula. So 25 times C, so your molecular formula is equal to 25 times 1. Remember there's an invisible 1 here. So 25 times that 1 is 25. So C25, and then we have H2. So there is a 2 here. So I'm going to say 25 times 2. 25 times 2 is what? 50. So H50. So that is to say that the molecular formula of this question is C25H50. And for us to prove that this is actually correct, remember we said the empirical formula is the simplest ratio of your molecular formula. If you break down 25 and 50 to its simplest ratio, what you have is 1 and 2. So the molecular formula of this compound is C25H50. I hope you understand. So if you have understood what I have explained, I would love us to attempt the next question on our own. So pause the video, attempt to solve, then when you are done solving, you can play the video back to see if you are correct or take correction. Okay, so let's solve the next question. Number 2. So the question says, caffeine has the following composition. We have 49.48% of carbon, 5.19% of hydrogen, 16.48% of oxygen, and 28.85% of nitrogen. The molecular weight is what? 194. Find the molecular formula of this compound. So you see that this question did not make reference to empirical formula, but like I previously explained, when you are solving for molecular formula, you must first of all solve for empirical formula. So using the format that we have been using, the first thing we're going to write is what? Our elements. So we have carbon, we have hydrogen, we have oxygen, and we have nitrogen. So that's what we have. Okay, so we're going to be writing our percentage. So 49.48, then we have 5.19, we have 16.48, and then we have 28.85. Okay, so that's our percentage. Now the next thing is to write what? The mass number. So please, not atomic number, mass number. But for this question, we're giving mass numbers in a bracket, so we appreciate that. So carbon is 12, hydrogen is 1, oxygen is 16, nitrogen is 14. Please learn your mass numbers. So we're going to be dividing this very quickly. So we have 49.48 divided by 12. So what we have is 4.12. Okay, so 4.12. Remember I said it must be two numbers after the decimal. So of course we know that this will be 5.19. So let's divide this. So we have 16.48 divided by 16. So we have 1.03, and then lastly 28.85 divided by 14, and we have 2.06. So you see two numbers after the decimal for all of them. So what's the next step? Is to select the lowest out of these four. So what is the lowest? So we know that it is 1.03. So we're going to be dividing them all by 1.03. Okay? So we already know that this is going to be 1. So let's divide this. 4.12 divided by 1.03. What we have here is 4. So it has a whole number. 5.19 divided by 1.03. And what we have here is 5. So lastly, 2.06. So what we have is 2. So we're giving whole numbers. Okay? So remember, please take notes in case I forgot to say. Your final answers must be whole numbers. So even if you have 2.06, remember 2.06, 6 is more than 5, so it becomes 1 for the next number. But 1 is not up to 5, so it remains 2. Okay, so your final numbers must be what? Whole numbers. So now that we've gotten that, our empirical formula is equal to C4, okay, C4, H5, O, remember it's 1, we don't write 1 in chemistry, and 2. So this is what our empirical formula. Now to calculate molecular formula, as I said, we're going to be adding up the mass numbers of your empirical formula. So carbon is 12 to get the relative molecular mass. So carbon is 12. 12 times 4, there's 4 attached to it, plus hydrogen is 1 times 5, plus oxygen is 16, there's nothing attached to it, plus nitrogen is 14 times 2. So let's quickly do that. So 12 times 4 plus 1 times 5 plus 16 plus 14 times 2. So what we have is 97. So what we have is 97. So let's say 97N. So we're going to be dividing our 97 by the molecular weight given in the what? Question. So therefore, 194.19 divided by 97. So let's quickly do that. 194.19 divided by 97. So what we have is 2.00, which is what? 2. So as we've gotten our 2, we're going to be using our final answer to multiply our what? Empirical formula. So 2, so let's write it here. Molecular formula is equal to 2 times 4 is 8, so C8. 2 times 5 is 10, H10. 2 times 1, remember it's an invisible 1 here, so O2. And then 2 times 2 is 4, and 4. So this is our molecular formula. I hope you can see it clearly. So let me just clean what is above so that we're not confused. So our empirical formula is C8. Good. So our empirical formula, our molecular formula rather, is C8, H10, O6, and 4. So this is the molecular formula of caffeine. I hope you understand. So this is not difficult at all. Please take out time to practice more questions. Practice makes perfect. Go online, search questions. If you come across questions that are too difficult for you, always reach out to me on my channel, leave messages. Also, if you have questions pertaining to this explanation, please let me know in the comment section below. If you have watched this video up to this point and you are yet to like, share, or subscribe, please kindly do so. So that said, have a wonderful day.